Well, I think we can get the answers to quiz 3 with just a few explanations. Question 1. That is the situation, and you're asked to find the force on 3 microcoulomb. Okay. The -5 microcoulomb attracts the 3 and the 2 microcoulomb repels it. So the force on it is in the same direction. Call them force on 3 due to 5 and force on 3 due to 2. That's how you read it. And the force on 3 due to 2. Remember, the formula is KQ1 Q2 by R squared. 3 times 2, both are in microcoulombs, so I'm going to put 10 to the negative 12. It's 10 to the negative 6 times 10 to the negative 6. Okay. Similarly, force on 3 due to 5, again 10 to the negative 12. Then the total force, simply add these two. K is 9 times 10 to the 9. 0.189 newtons. Question 2. Q is equal to NE, 2 microcoulomb, N times the charge of the electron. (1.25 times 10 to the 13). Question 3. A force of 10 newtons acts on a charge of 5 microcoulomb. When it is placed in a uniform magnetic field, what is the magnitude of this electric field? Okay, simply E is F by Q, force is 10, the charge on which that force is 5, acts as 5 microcoulomb, divide, the field is 2 times 10 to the power 6 Newton per coulomb. Number 4, this is the situation. 3 microcoulomb on 3 corners, and the fourth one -3 microcoulomb. First of all, you have to find the distance from the center to each corner, and it's going to be half of that distance. So actually the diagonal is going to be 0.5 times √2, but when you take half of that, you will get 0.5 divided by √2. Well, it's not 0.707. I'm going to change that. And the forces due to 2 and 3 definitely cancel out, as you see. But the forces due to 1 and 4, they add up. And also the force due to 1 and the force due to 4 are equal, both given by this formula. Okay, so now that I've corrected it, it's 0.35. Alright. And you get this force as 216, so you got to double it. And you get the answer as 432 times 10 to the 3 newtons. 5. Straightforward question. Five and 1 nanocoulomb, so distance 10 meters. So 0.45 Newton. 6. The weight of the particle must be balanced by the electric field. So mg, which is the weight, should be equal to QE. Rearrange. All the quantities are given. You get 12.25 times 10 to the 3, which is 1.2 times 10 to the 4 Newton per coulomb. 7. What is the charge on 1 kilogram of protons? First find the number of protons. Divide the mass by the mass of 1 proton. Get the number of protons, and you know that the charge on a proton is of the same magnitude as that on an electron. So to find the total charge, use Q is equal to NE. And the answer is 9.6 times 10 to the 7. Question 8. Charge is 40 times the electronic charge. So first find the charge, and then know that E is KQ by R squared. (5.76 times 10 to the negative 8). In the 9th one, this is the situation. That is 0.30. That is the origin, and that is 0.1. And these are the charges. Well, the force on 5 due to 6 is repulsive, and the force on 5 due to negative 1 is attractive. So that's the direction of the two forces. Force on 5 due to 6. Well, that's the formula. It's 5 times 6 times 10 to the negative 18, because both are nanocoulombs. Force on 5 due to 1. And you're asked to find the direction. So let's say that the angle that's made with the negative x-axis is theta, and from there tan theta is opposite side, which is f phi 1, divided by the adjacent, which is f phi 6. Take the inverse of that to get approximately 56 degrees above the negative x-axis. In the 10th problem, you have 5 microcoulomb at 0, minus 4 at 50 centimeter, which is 0.5 meter, and you have to find at what point is the electric field 0. It has to be on the outside and closer to negative 4. And to find the field, you imagine that there is a plus 1 coulomb kept there, and the forces on that has to be equal and opposite, because the negative charge is going to attract it and the positive 5 coulombs is going to repel it. And we know that. I'm calling it F14 and F15. And each of these forces is given by K, Q1, Q2 by R squared. Carefully note the distances. They both must be equal. Set them equal to each other. Cancel the quantities. Take the square root on both sides. Cross multiply. collect the x terms, and you get x as 4.2 meter, but the total distance from the 0 mark would be 0.5 plus 4.2, which is 4.7 meter. Well, I believe that you have now understood how to do all these 10 problems. Thank you.